The topic for this video will be the different rules in differentiation, which involves algebraic expressions. Here are the topics that we're gonna discuss. The constant rule, power rule, constant multiple rule. Why do we need to learn these rules? C. Finding a function's derivative using the limit definition can be time-consuming and tedious. Knowing these rules will enable us to find the derivative of even complicated and complex functions. Let's start with the most basic rule, which is the constant rule. The derivative dx of c, where c represents any constant value, is equal to 0. Let's take 5 for example. The derivative with respect to x of 5 is 0. Remember that this rule also applies to irrational numbers. For instance, pi, which is a numerical value of approximately 3.1416. Now, the derivative with respect to x of pi is 0, since pi is a constant value. Same goes with the Euler's number e. The derivative with respect to x of e is also 0. Now, what is the derivative of 7 to the power e? Since the function has no x variable, the derivative of 7 to the power e will be 0. Now that is the constant rule. The derivative will always be 0 if the function has no variable. The next rule is what we call as the power rule. The power rule states that dx of x to the power n is equal to n times x to the power n minus 1, where x is the variable and n is the exponent. Let's have an example. What is the derivative with respect to x of x squared? In this case, the value of exponent n is 2. The derivative will be n, which is 2, times x to the power 2 minus 1. 2 minus 1 is 1, therefore we have 2 times x to the power 1, or simply 2x. Notice that we just bring down the exponent in front as a constant multiple and subtract 1 in the exponent. 2x is the derivative of x squared. Let's have another example. Say we have x. Go ahead and try to find its derivative. Remember that we can write this function as x to the power 1. By power rule, the derivative of x will be bring down the power, which is in this case 1, times x to the power 1 minus 1. We have 1 times x raised to 0. Now x to the power 0 is 1, and 1 times 1 is 1. Thus, the derivative of x is 1. How about x cubed? Dx of x cubed will be the power, which is 3, times x to the power 3 minus 1. 3 minus 1 is 2. Thus, the derivative of x cubed is 3x squared. Now let's use the power rule to find the derivative with respect to x of x to the power 4 and the derivative with respect to x of x to the power negative 7. For x to the power 4, we bring down the exponent 4 times x, then subtract 1 in the exponent. We got 4 minus 1. The answer will be 4x cubed. For x to the power negative 7, we have negative 7 times x to the power negative 7 minus 1. Negative 7 minus 1 is negative 8. Then it is equal to negative 7 x to the power negative 8. See that the exponent here is negative. We can get rid of the negative sign by putting the term below as our denominator. Therefore, we have negative 7 divided by x to the power 8. And this will be the answer. That is how you apply the power rule. We need to remember this formula. Now, how can we derive a function such as 3x squared? We have what we call as the constant multiple rule. We can write it as dx of k times f of x is equal to k times f prime of x. The derivative of the constant k multiplied by a function is equal to the constant k times the derivative of that function. Let's apply this formula to solve for the derivative of 3x squared. In this case, the constant k is 3 and the function is x squared. The derivative will be the constant, which is 3 times the derivative of that function x squared. It is equal to 3 times, we will apply the power rule to derive x squared. We put the exponent, which is 2, on the front, times x to the power 2 minus 1. Now 2 minus 1 is 1. The derivative will be 3 times 2x. We get the answer, which is 6x. And this is the derivative of 3x squared. That is how you apply the constant multiple rule. Now let's have another example. What is the derivative of pi divided by x to the power 5? Go ahead and try to figure out how to solve this question. You can pause the video and play it again once you're done. First, let's separate the constant. We can write the function as pi times 1 divided by x to the power 5. Notice that the denominator is x to the power 5. From algebra, we can rewrite this function by putting x to the power 5 on top, but it must have a negative exponent. Therefore, we can write it as x to the power negative 5. The function will be pi times x to the power negative 5. Now let's apply the constant multiple rule to find the derivative of this function. The derivative should be equal to the constant, which is pi, and multiply it with the derivative of this function. By applying the power rule, we put negative 5 on the front, negative 5 times x to the power negative 5 minus 1. Negative 5 minus 1 is negative 6. Therefore, the resulting value will be pi times negative 5 times x to the power negative 6 equals negative 5 pi x to the power negative 6. This is our answer. However, if you want to, we can simplify this further to get rid of the negative exponent. We will make this term as the denominator and change the sign of negative 6. We will get negative 5 pi on top and x to the power 6 on the bottom. This is our answer in simplified form. What if the function is inside the radical sign? Say for example, how can we derive square root of x? We need to remember that b root of x to the power a is equal to x to the power a divided by b. The exponent of the variable will become the numerator a, and the index will become the denominator b. For square root of x, the exponent a is 1, and the index is 2. Square root of x can be written as x to the power 1 over 2 or 1/2. Notice that we can also apply the power rule to find the derivative. The derivative is equal to the derivative with respect to x of x raised to 1/2. We have 1/2 times x to the power 1/2 minus 1. 1/2 minus 1 is negative 1/2. F prime of x is equal to 1/2 times x to the power negative 1/2. Let's eliminate the negative sign in the numerator by moving it to the denominator. F prime of x is equal to 1 divided by 2 times x to the power 1/2. Remember that we can rewrite x to the power 1/2 as square root of x. The answer will be 1 divided by 2 square root of x. Let's try another problem. What is the derivative with respect to x of 8th root of x to the power 9? Go ahead and try this one. Let's convert this to fractional exponent. We get the derivative with respect to x of x to the power 9 divided by 8. The exponent 9 will be on top, while the index 8 will be on the bottom. Now by power rule, we have 9 divided by 8 times x to the power 9 divided by 8 minus 1. 9 over 8 minus 1 is equal to 9 over 8 minus 8 over 8. 9 minus 8 is 1. We get 1 divided by 8. The derivative will be 9 divided by 8 times x to the power 1 divided by 8. In this case, 1 is the exponent and 8 is the index. We can rewrite this as 9 8th root of x to the power 1, or simply x over 8. This is the final answer in simplified form. Let's review the formulas we have used in this video. The derivative with respect to x of a constant value c is 0. We also have the power rule. The derivative with respect to x of x to the power n is equal to n times x to the power n minus 1. The constant multiple rule. The derivative with respect to x of k times f of x is equal to k times f prime of x. We need to familiarize these formulas to find the algebraic functions' derivatives. We can also apply some of these fundamental rules in our next topic. Thank you for watching and see you in the next video.